So this video will be about delta, and at first glance it might seem that there is a lot going on, but please don't worry, it's not as hard as it looks like. The curriculum is presenting a few formulas that can be quite hard to understand without context, so I'm going to enrich this with a concrete example that I've covered in my earlier lessons. Please keep in mind this will be just a conceptual walkthrough, so with that said, let's get right into the content. So in the curriculum you will see two graphs placed side by side, but over here I've arranged them one above the other, and the upper graph shows the delta of a call option, while the lower one shows the delta of a put option. Notice that the delta of the call option is positive, while the delta of the put option is negative. And the reason for that is straightforward. When the underlying price increases, the value of the call option increases as well, which indicates a positive correlation. Whereas in the case of the put option, if the price of the underlying increases, the value of the put option is decreasing, which of course is indicative for negative correlation. And what I want you to notice over here is that in the case of the call option, the lower the value of the underlying, the deeper out of the money the call option will be. And the higher the price of the underlying, the deeper in the money the call option will be. And if the call option is deep in the money, it is very likely to be exercised, which effectively means that we are long the underlying, hence the delta is close to 1. Now, if the call option is deep out of the money, it is very unlikely to be exercised, so there is no effective position, which basically justifies a delta close to 0. And the very same logic applies to put options, because in this case, the lower the price of the underlying, the deeper in the money the put option will be. And conversely, the higher the underlying price, the deeper out of the money the put option will be. And if the put option is deep in the money, it is very likely for it to be exercised, which basically implies a short position in the underlying, hence delta is close to -1. Now, if the put option is deep out of the money, it is very unlikely for it to be exercised, which basically means that there is no effective position and the delta would be close to 0. Now, the curriculum presents a few formulas for the delta of a call and a put, but I think that these are hard to understand without a concrete example. So let me revisit a numerical example that I've covered in my previous lessons, just to show you the big picture. Now again, I just want to give you the big picture, so please don't get lost in the detail, because the point is to understand the mechanics and the overall idea. So in the example that I've covered in my previous lessons, we were given certain inputs, such as the price of the underlying, the strike price, the risk-free rate, the volatility of the underlying, and the time to maturity. And based on these inputs, we answered the question of what is the value of both a call option and a put option. And here we can see the classic Black-Scholes formula for a call option and a put option, where D1 and D2 are expressed through these formulas over here. And by performing all the calculation, the end result was that the theoretical value of the call option is this value over here, and the theoretical value of the put option is this value over here. And as you can observe, it looks like a simple plug and play, because we are given all the necessary inputs except for these guys over here, which we need to determine using the cumulative distribution function. And let me walk you through these from a big picture perspective. So in order to calculate these values, we first need to calculate D1 and D2, which is a simple plug and play. So once we plug in the inputs, we would get D1 to be this value over here, and D2 to be this value over here. And once we have these values, we need to plot these on the cumulative distribution function for both the call and the put. Now, please keep in mind, this is the cumulative distribution function of a standard normal distribution with a mean of 0. So if we plot D1 and D2 for the call option, D1 would be somewhere over here, and D2 would be somewhere over here. In the same fashion, if we were to plot minus D1 and minus D2 in the case of the put option, minus D1 would be somewhere over here, and minus D2 would be somewhere over here. And basically, what I want you to understand is that ND1 is the surface under the curve from minus infinity until D1. And if we look this up in the statistical tables, we would get this value over here, and this value over here is basically the delta of the call option. Now, in the case of the put option, the logic is similar, because in this case, n minus d1 is the surface under the curve from minus infinity until minus d1. And of course, this value can be looked up in statistical tables. And notice how this value is a positive value, which basically implies that this value is the absolute value of the put's delta. And basically, what I want you to be aware in this case is that this value is the absolute value of the delta of the put. And this is because, as I illustrated on the left, the delta of the put is a negative value. And the curriculum is giving us two formulas to come up to the delta of the put option. And the first one is basically delta call minus 1, which if we plug in the numbers, we would get the negative value as expected. Or an even simpler method, which I suggest, is to simply take the negative of the cumulative distribution function, which will also result in the same value. Now, this is not something that is explicitly mentioned in this section, but I thought it would be a nice reminder since we have the Black-Scholes model in front of us. Let me just remind you that ND2 and N minus D2 represent the surface under the curve until those points, which again can be looked up in statistical tables. And basically, these terms represent the risk-neutral probability that the options expire in the money. So let me wrap everything up. Basically, ND1 is the delta of the call option, N minus D1 is the absolute value of the delta of the put option, while ND2 and N minus D2 are the risk-neutral probabilities that the options expire in the money.